Hello, I'm covering section 1.4 today on quadratic equations. So we spent some time. Well, the first two sections in this course were about linear equations. The last one was about complex numbers, and we're going to need complex numbers to write some solutions of quadratic equations whenever it is the case. Okay, so this a quadratic equation is. Now we have a term with x squared. This on page 113. An equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers, with a not equal to 0 is a quadratic equation. And the given form, the form that we see here, is called standard form. So we're going to see methods for solving a quadratic equation. So the following methods allow us to solve quadratic equations. The most basic one, and the first you probably learned when learning elementary algebra, is factoring. Sometimes it is more convenient to use the square root property. And for any quadratic equation, you can solve it by completing the square. This one, I'm just going to mention it. A consequence of completing the square is the quadratic formula. So the quadratic formula is going to be more direct than completing the square, but in order to prove the quadratic formula, we need to complete the squares. Okay, so when solving by factoring, we use the zero factor property. That's on the same page, page 113. If a and b are complex numbers with a times b equals 0, then either a 0 or b 0 or both are 0. So that's what we do when we solve an equation by factoring. We need the zero factor property. So that's the most basic method, factoring. But and whenever you can factor a quadratic expression, that's the method you're going to use. So we're going to solve the equation by factoring. And using the zero factor property, the equation is 2x squared minus 9x minus 5 equals 0. So every time we have an equal sign, we write the expressions. We have an equation, or the statement is an equation. Okay, so we can do this by factoring. So this expression can be factored, and that's what we're going to do. If not, we're going to use either completing the square or using the quadratic formula. But we can factor the left-hand side. So 2x squared, we can factor that as 2x and x. We want the product of the last terms to be minus 5, and the combinations to be minus 9. So we can Yeah, we can do 2x plus 1 and x minus 5. So 2x times negative 5 is minus 10x. Minus 10x plus x is going to be minus 9x. And then the zero factor property. Either 2x plus 1 equals 0 or x minus 5 equals 0. So if x minus 5 is equal to 0, x is equal to 5. 2x plus 1 equals 0, that means 2x is negative 1, and x is negative 1/2. So x equals negative 1/2, and x equals 5 are still equations. The solution set is going to be minus 1/2 and 5. Okay, so that's the most basic method, or the first method that you learn is solving an equation by factoring. Other times it's going to be more convenient to use the square root property. The square root property says the following. That's on page 114. If x squared is k, if x squared is equal to k, then x is square root of k, or x is the opposite of square root of k. And in that case, the solution set of this equation is minus square root of k, comma square root of k. If k is negative, you're going to have imaginary numbers. If it's positive, you're going to have real numbers. So we're going to solve the following equations by using the square root property. Okay, number one. In the first example, we are going to solve 2x squared equals 10. If we're going to use the square root property, we are going to isolate x squared. We can do this by dividing by 2. And x squared is 5. So x is plus minus square root of 5. And that is the solution set. The solution set is minus square root of 5, square root of 5. Number 2. Solve by using the square root property, x squared plus 19 equals 3. Step number 1. We need to isolate x squared on one side. We can do this by subtracting 19 from both sides. And x squared is negative 16. So x is plus minus square root of negative 16. But you know at this point that if you have been watching the videos, square root of negative 16 is 4i. And that is the solution set. Is minus 4i, comma 4i. Number 3. Solve the quadratic equation, x plus 2 squared equals 8. Okay, so we have that the expression on the left side is the square of something. So we can use the square root property. If x plus 2 squared equals 8, x plus 2 is plus minus square root of 8. Now, square root of 8 is the same as square root of 4 times 2. Or 2 times square root of 2. Okay, so x plus 2 is plus minus 8, or plus minus 2 square root of 2. So x is minus 2, negative 2 plus minus 2 square root of 2. And that is the solution set. Okay, so that's negative 2 minus 2 square root of 2 and negative 2 plus 2 square root of 2. Okay, so this one I'm just going to mention one example for the next method. It's solving a quadratic equation using completing the square or by completing the square. Okay, so I'm going to copy the procedure. This is on page 115. So to solve ax squared plus bx plus c equals 0, where a does not equal 0 using completing the square, follow the steps. If a does not equal 1, divide each side of the equation by a. Second step, rewrite the equation so that the constant is alone on one side of the equality symbol. So we're going to have the terms with x on one side and the constant on the other side. Step 3, square half the coefficient of x and add the square to each side of the equation. Step 4, factor the resulting trinomial. So the idea is to have a perfect square trinomial as a perfect square and combine like terms on the other side. And finally, use the square root property to complete the solution. So now this seems like a bunch of words. I'm going to do 2 examples. One where a is 1, and another one where a does not equal 1. Okay, we're going to solve x squared minus 6x minus 3 equals 0. So we can use directly factoring or the square root property. We're going to do that, but we cannot factor that expression. X squared minus 6x minus 3. That's not easy to factor. So we need to complete the square or use the quadratic formula, but the quadratic formula is a consequence of completing the square. Okay, so step number one. In the first step, we write the terms with x on one side and the constant on the other side. Step number two. Step number two, rewrite the equation so that the constant, well, we already did that. So step number one, there was nothing to do. We did steps 1 and 2. Yeah, there was nothing to do on step 1. Step 3, square half the coefficient of x and add the square to each side of the equation. So the coefficient of x is 6. We know that negative 6 over 2 is negative 3, and negative 3 squared is 9. So we are going to add 9 to both sides of the equation. That way, we have a perfect square trinomial on the left. So that's factors as x minus 3 squared, and 3 plus 9 is 12. So now we have something. We have an equation that can be solved by using the square root property. And step number 5, we're going to find the solutions. So x minus 3 is plus minus square root of 12. Where do you know? Square root of 12. Square root of 12 is square root of 4 times 3, or 2 times 3. Or, sorry, 2 square root of 3. Okay, so x is 3 plus minus 2 square root of 3. And that is the solution set. And I'm going to do another example where the leading coefficient is not 1. Well, actually, I'm going to separate them because I'm going to write it the way my MATLAB is asking you to write. So what we wrote is correct, but in on my MATLAB, they want you to write this in a comma separated list. So we're going to do that. And we're going to do another example where the leading coefficient is not 1. Okay, we're going to solve for x squared plus 4x plus 7 equals 0. So again, we have an expression that cannot be factored, or it can be factored, but it's not easy to factor. So we're going to complete the square. So step number 1. If the leading coefficient is not 1, we divide everything by the leading coefficient. That is, we divide each term by 4, by the leading coefficient 4. So we're dividing everything by 4, and x squared plus x plus 7 over 4 equals 0. Step 2, we are going to write the terms with x on one side and the constant on the other side. And the idea is to have to be able to use the square root property. So we can do that by adding half of the coefficient of x to both sides. So we have a perfect square trinomial. So the term with x is 1. You know that 1 squared is 1/4. Sorry, 1/2 squared is 1/4. So we're adding half the square of the leading coefficient, or we're adding the square of half the leading coefficient to both sides. So now we can factor the left-hand side as a perfect square trinomial. And finally, we can, this was, by the way, this was step 3. So we did step 3. Step 4, let's see. Yeah, step 4, we factor. And you know, math is not, it's not about memorizing steps. I'm just following the guidelines, but math is not about memorizing steps. So it doesn't matter, as long as your procedure is correct, doesn't matter whether you remember the step numbers. Okay, step 5, we're going to solve by using the square root property. So x plus 1/2 is the square root, or is plus minus the square root of -6/4. Or this is plus minus I square root of 6/4. Square root of 6, we will not be able to simplify that, but we can do something about the 4. So this is plus minus I square root of 6 over square root of 4. And square root of 4 is 2. So x plus 1/2 is plus minus I square root of 6/2. So x is -1/2 plus minus I square root of 6/2. Or square root of 6/2 I. So the solution set is going to be that. So these are going to be the solutions. The solutions are complex, and they come in conjugate terms. And finally, the fourth method is the quadratic formula. I'm not going to prove it, but we obtain the quadratic formula by completing the square. Okay, so for the quadratic formula, as you can see, if the leading coefficient is not 1, we make the leading coefficient be equal to 1. Then we complete the square, except that we have letters that can be any numbers. And by completing the square, we get the quadratic formula. I'm not going to go over the details of the proof. I just want you to know that this is the quadratic. Page 117. The solutions of the quadratic equation ax squared plus bx plus c equals 0, where a does not equal 0, are given by the quadratic formula given below. X is minus b plus minus square root of b squared minus 4ac over 2a. So these are going to be the last examples. And that expression inside the square root, that's called the discriminant. I'm going to talk about that. Okay, first example. Is 2x squared equals minus 4x plus 9. So if we're going to use the quadratic formula, we need to write in standard form. That is 2x squared plus 4x minus 9 equals 0. And we can use the quadratic formula where a is 2, b is 4, and c is negative 9. Okay, so let's put this in. Let's plug this in. Let's plug it in. Let's plug it in the quadratic formula. So x is the opposite of 4 plus minus the square root of 4 squared minus 4 times 2 times negative 9 divided by 2 times 4, 2 times 2. So x is minus 4 plus minus 4 squared is 16. 4 times 2 is 8. 8 times 9 is 72. And then we have minus plus minus. So that's going to be plus 72 divided by 4. 16 plus 72 is 88. Then 88. Let's see. We want to. We can simplify this a little bit. 88 is 4 times 22. Or I can just go ahead and write it as a square root. So this is square root of 4 times square root of 22. I'm trying to erase that. Okay, so it's so I'm going to close the screen for a moment, or I'm going to close the whiteboard for a moment and try to open it again. So let's try again. Okay, so let's come back to where we were. Okay, so this is where we were. So this is square root of 8. So this square root of 4 times square root of 22. Again, that's square root of 4. That's square root of 22, or 2 square root of 22. Okay, so back to the solutions. X is minus 4 plus minus 2 square root of 22 over 4. And we're going to separate the solutions. We're going to write them in a comma separate list. So that's minus 4 over 4 plus minus 2 square root of 22 over 4. Where 2 over 4 simplify as 1/2. So this is minus 1 plus minus square root of 22 over 2. Yeah, so this 2, we can reduce the fraction as 1 over 2. Okay, so the solution set it's -1 minus square root of 22 over 2, and -1 plus square root of 22 over 2. Okay, next example. We are going to solve 2x squared plus x plus 3 equals 0. Again, that's an equation that the factorization is not clear. It can be done by factoring, by using irrational numbers or complex numbers, but it's not clear. Whenever it's not evident, we're going to use quadratic formula, where A is 2, B is 1, and C is 3. So let's plug this in the quadratic formula. This is -1 plus minus 1 squared minus 4 times 2 times 3. Over 2 times 2. Okay, so this is -1 plus minus 1, and then 4 times 2. 4 times 2 is 8. 8 times 3 is 24. Divided by 4, so it looks like we're going to have complex solutions. So if we separate the terms, those are -1 over 4 plus minus square root of -23 over 4. The square root of -23 is square root of 23 times I. So that is going to be the solution set. Okay, the solution set is -1/4 minus square root of 23 over 4i, and -1/4 plus square root of 23 over 4i. Okay, final answer. And the last topic is the discriminant. That gives you important information about the number and type of solutions. Okay, so I'm going to read this. The quantity under the radical in the quadratic formula, b squared minus 4ac is the discriminant. So that's whatever is at the square root is called the discriminant, and that can give you important information. So I'm going to copy this table. Okay, so given a quadratic equation where the solutions are the opposite of b plus minus square root of b squared minus 4ac the quantity inside the square root is called the discriminant. And that can give us important information, or that can be useful to determine the number and type of solutions. Okay, so when the discriminant is positive in a perfect square, so a perfect square is a number like 9, whose square root is 3, or 16, whose square root is 4, or 25, whose square root is 5. So if the discriminant is positive in a perfect square, there are going to be two real solutions, and they're going to be rational. If the discriminant is positive, but it's not a perfect square, the solutions are going to be irrational. That is, the solutions are going to involve square roots. If the discriminant is 0, there is one or a repeated solution, which is going to be rational. And when the discriminant is negative, there are going to be two non-real complex conjugate solutions. So we did the previous examples. So in the first example we did, the discriminant was this. The discriminant was 88. That was well, the discriminant was 88. Actually, I'm going to write those. Okay, so we did the following examples. And we did first we did 2x squared plus 4x minus 9 equals 0. And the discriminant was 88. Which is not a perfect, it's positive, but it's not a perfect square. So that had two irrational solutions. And the other example I did was 2x squared plus x plus 3 equals 0. The discriminant was negative 23. Which is negative, and the equation had two complex solutions. Two non-real complex solutions, which were right away complex conjugates. Okay, so I'm just going to do a few more. I'm going to do the last examples. We're not going to solve anything. We're just going to determine the number of solutions and the type. We are going to evaluate the discriminant. And determine whether the equation has rational, irrational, or complex solutions. Example number 1. The equation is 3x squared plus 2x minus 5 equals 0. We're not solving the equation. We're just going to use the discriminant to determine the number and type of solution. So A is 3, B is 2, and C is negative 5. The discriminant it's b squared minus 4ac. So that's 2 squared minus 4 times 2 times negative 5. 4 times 2 is, so 4 times 2 is 8. 8 times 5 is 40. Let's see. Okay, so I'm making a mistake. That's a 3. That was 3. That was not 2, that was 3. Okay, so 2 squared is 4. 4 times 3 is 12. Times 5 is 16. And then minus plus minus is plus. So that is 64. And the square root of 64 is 8. So the equation has two distinct rational solutions. That is something that we could have done by factoring. Number 2, same question. We are going to solve 2x squared plus 3x equals negative 11. Okay, we're going to write the equation in standard form. The discriminant is going to be b squared minus 4ac. So that's 3 squared minus 4 times 2 times 11. So 3 squared is 9. 9 plus 88, or 9 minus 88, which is going to be negative 79. So that one is negative, and the equation has two distinct complex solutions. Number 3. Find the discriminant and determine the number of types of solution of negative 9x squared minus 6x equals negative 1. Okay, standard form. This is 9x squared minus 6x plus 1 equals 0, and the discriminant it's negative 6 squared minus 4 times 9 times 1. So negative 6 times negative 6 is 36. 4 times 9 times 1 is also 36. And that equation has one double rational solution. And number 4, so we have done one of each case. We did first case, 2 distinct rational solutions. Second case, 2 distinct complex solutions. Third case, 1 double rational solution. So by elimination, the last case is going to be 2 distinct irrational solutions. So number 4. The equation is 5x squared equals 5x plus 7. So let's write in standard form. The discriminant is what? This negative 5 squared minus 4 times 5 times negative 7. So that is 25. And then minus plus minus is plus. 4 times 5 is 35 times 7. Oh, so sorry, 4 times 5 is 20. 20 times 7 is 140. Now, since 165 is not a perfect square, the equation has 2 distinct irrational solutions. Okay, thank you for listening.